Hello friends, this video on Semiconductors Part 19 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 18 before going ahead with Part 19. So we go another level up, right? So far we started our discussion with what is semiconductor, the types of semiconductor, p-type semiconductor, n-type semiconductor, p-n junction, and then junction diodes, and now we come to junction transistors. So junction transistors were an excellent development of semiconductor electronics. This junction transistor were helpful, and it was able to successfully replace the valves completely, as I mentioned in our introduction slides. So let us see what is a transistor. So here in this, however, there are many different types of transition, not only junction transistors. These junction transistors are also known as bipolar junction transistors. But since in this lesson we are only discussing about bipolar junction transistors, so we will call it as transistor. So what is a transistor? A device with three connections which is capable of amplification in addition to rectification. In the case of diodes, we saw that it was a two-terminal device, right? But in case of transistor, it has got three terminals. So the transistor is capable of amplification in addition to rectification. That means the transistor serves the purpose which diode served. Diode also helped in rectification, but in addition to rectification, the transistor is also capable of amplification. It consists of three doped regions forming two p-n junctions. Now you must be thinking, what are these three doped regions? Because in diode we had just two regions, the p region and the n region. But in case of a transistor, since it is a three-terminal device, so it has got three doped regions forming two p-n junctions. That means it is of this form. We have one type called NPN, where you have first an n-type semiconductor, then a p-type semiconductor, and then again an n-type semiconductor. And the second one is PNP, where a p-type semiconductor is followed by an n-type semiconductor, which in turn is followed again by a p-type semiconductor. Right? So these are broadly the two types of transistor, PNP and NPN. Right? So here you can see that now we have got two p-n junctions. This is one junction between this n and p. This is another junction between this p and n. So in this case we have got two p-n junctions. What is the symbol for a transistor? So this is how we denote a transistor. So when I talk about NPN transistor, we have this symbol. This denotes emitter, this denotes base, and this denotes collector. You must be wondering what are these. I'll discuss each of them in detail in the next slide. Here I am just telling you how the symbol looks like. Now what is this arrow for? This arrow shows, like for example, in case of a diode we had this arrow, right? So what was this arrow for? This arrow showed the direction of conventional current. Similarly, in this case also, you have this arrow which shows the direction of conventional current. In PNP, if you see, the symbol remains the same, just that the arrow sign changes because the direction of conventional current changes. Now why is the arrow inwards in case of PNP and outward in case of NPN? That you will understand once I teach you about the working of a transistor. So for now, just look at the symbol. Whenever it is NPN, the symbol will be towards emitter. Whenever it is PNP, it will be towards base. Right? So now let us understand what are the different doped regions of the transistor. Just now I told you there are three doped regions. What are the three regions called? They are known as emitter, base, and collector. These are the three regions. So what is emitter? So when I say emitter, emitter is the region at one corner, right? So one end is emitter, which is heavily doped and moderate size. Also to note that these three different doped regions of the transistor, they are of different sizes depending upon their function. They are also doped differently depending upon their function. Some will be moderately doped, some will be very lightly doped, some will be very highly doped, right? So emitter is the one which is heavily doped, because as the name suggests, emitter emits the charge carriers, right? So if it is heavily doped, then it is good. It will be able to emit a large number of carriers, right? Okay, but the size of the emitter is moderate. It is neither very large nor very thin. Okay, so the next region is base. Base is the central segment which lies between emitter and collector. It is lightly doped. So base is lightly doped because base is the intermediate region, right? So it is not the source of current carriers. So since emitter is the source of current carriers, it is heavily doped so that it can contribute many charge carriers. But base is lightly doped and it is very thin as well. Okay, now why is the base lightly doped, that you understood, but why is it very thin, that we will discuss when we discuss the working of the transistor. The third region is the collector, which is again moderately doped. So as far as doping is concerned, collector, as the name again suggests, collector is the one which will collect the charge carriers. So emitter will emit the charge carriers and collector will collect them. So the one who has to collect the charge carriers, there doesn't need to be very highly doped. So that's why collector is moderately doped. However, the collector is larger in size. So if you look at the three segments, collector is the one which is the largest in size and base is the one which is the smallest in size. So collector is largest in size. That's because its purpose is to collect all the charge carriers. So it should have enough space to collect all the charge carriers. So this is how we define the three different regions, that is the emitter, the base and the collector. So these three regions together will form a transistor, right? So now the junction between the p-n junctions which we have, what do we call them? This junction is known as, the junction between the emitter and base is known as the emitter base junction. Similarly, the junction between the base and the collector is known as the base collector junction. So the junction between these two is known as base collector junction. Junction between emitter and base is known as emitter base junction. So this is my emitter base junction and this is base collector junction. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.